All right, now we're going to talk about slope fields. Imagine you're an artist and you want to describe a hillside with mathematics. Just imagine some great mathematician took a differential equation, just scattered it over your hillside. What would that pattern be like? Well, it would depend upon where you were and what the slopes look like and what sorts of functions he threw out there. They might be grasses, they might be sunflowers, they might be bluebonnets. So just keep that in mind as we do slope fields. Now, let's look at this function right here. Suppose I tell you that this slope field, this is a slope field of this differential equation. Are you going to believe me? No, don't. Well, do, because we'll be showing you how to calculate these slope fields in a bit. But for right now, just have a little bit of faith, and this is the correct slope field. If I were to draw curves along these slope fields, you see I can almost get what this curve is supposed to look like. All right, as I go through, and I'm not doing a very good job of this, because I actually shouldn't be cutting across any slope fields. But you can see I'm sketching in particular solutions from this slope field. All right. It's a lot harder than think with a pen. Now, suppose I tell you that y equals c over x is a solution to this differential equation. Do you believe me? Well, you shouldn't. I mean, you should, but don't. Prove it to me. I'm going to solve this. Just clear the fractions, and now I'm going to take the derivative of both sides. So the derivative of both sides is xy prime is equal to plus, sorry about that. You know, I tell you never to cross out, so just draw lines through. Xy prime plus y equals 0. So when I solve this for y prime, this is negative y over x. So indeed, this is a solution to this differential equation. Y is c over x. So basically, if I look at the function x times y equals any constant, I'm going to get these curves. And as a matter of fact, I will as I change x, as x increases, of course, y is going to decrease, and vice versa. So this is interesting. Let's go on, and I want you to sketch slope fields at particular points. We're not going to do great big fields to start with. Let's just look at y prime is y minus x at these 3 points. So this is x, this is y. So I'm going to find the slope at this point, and that's negative 1 minus 1, so that's negative 2. Let me go and find the slopes, and then I'll do the sketches. I'll tell you what, let me go and do this. The slope at negative 1, positive 1 is negative 2. So you're going to put a short tick mark that's about negative 2 down. Now let me change colors. At 0, 1, y prime is 0 minus 1. It's negative 1. So at x equals 0, y equals 1, the slope is a nice little negative 1. Now let's go on to 1, 1. Y prime is x is 1, y is 1, it's 0. So we're going to put a little short horizontal line there. So the slope at those particular points are represented by these short little lines. Now you try it. Stop the tape, turn the tape back on, and when you're done, we will do something else. Now we're going to draw more general slope fields and identify slope fields. I want you to ask yourself a number of questions. The first question I want you to ask is, does the slope, and y prime is always a slope, depend upon x? If it does not depend upon x, then if we look at this, if x is the same value, then all these slopes should be the same. Otherwise, we're going to change. Does the slope depend upon y? Well, if it doesn't, then for any given y, all of the slopes should be the same. What happens when y is 0? What happens when x is 0? These tend to be really easy ones to look at. However, the most important question, at least when I do these, is where is the slope 0? Because the slope is going to be 0 wherever you're going to wind up with these little horizontal lines. You can also look at where is the derivative 1, where is it 2, etc. Where is it positive, where is it negative? So let's look at some equations. Now I've got 3 differential equations and 3 slope fields. Which one of these goes where? Oh gosh, I don't know. Let me pull them all out of the way to start with. What do you say we just pull up one of these equations? Let's start with this one right here. Y prime equals y. Where is the slope 0? And the slope here is 0 when y is 0. So let's look at y equals 0. Ooh, that's not it. Ooh, that's not it. Oh, that one's it. All right. So the slope when y is 0 is 0. Now let's look at what happens as we change y, because we want to make sure. When y is 1, all of these have a slope of 1. When y is 2, they all have a slope of 2. Oh, all the way up. And they get up here so high we can't tell the difference anymore. What happens when y is negative 1? These slopes are negative 1, negative 2, negative 3, on until they're too large to change. Now, I want to point out that the y's, when y is a given number, the slopes are all the same. So this does not depend on x. And the only equation we had that didn't depend upon x was this one. So we have quite a bit of verification for this particular differential equation and graph. All right, so let's pull up the next one. Do you care which one? Let's do this one right here. Y prime equals x. All right. Oh, goodness gracious. Where is the slope 0? And of course, the slope for this one should be 0 when x is 0, and that certainly isn't it. So let's look at this one. Okay, whenever x is 0, this slope is 0. Now, does this depend upon y? Well, let's look at this. It does not appear to change when my y value changes. Let's look at x equals plus 1. All of these are plus 1. When x is plus 2, they're all plus 2, and they keep going up. When x is negative 1, they're all negative 1. When x is negative 2, they're all negative 2. Okay, so you got the idea. Okay, let's look at the third one. Now, you might want to just go, oh, well, this has to be the answer. You need to check it. All right, this is 0. This is going to have a slope of 0 when x equals negative y. When x equals negative y. Is that the case? Okay, negative 2, negative 2. You know what? I'm just seeing this y equals negative x line here. Cool. Suppose I wanted to check a couple of points. Let me pick several points, x, y, and it doesn't matter what they are. Let's look at x equals 0. Then as x equals 0, the slope should increase as y increases. And lo and behold, that is what we see happens. So when y is 1, the slope should be 1. When y is 2, the slope should be 2, etc. And that's what we see happen. When y is negative 1, the slopes are all negative, and indeed, they do increase. Okay, you give it a go and see if you can do this one. And pause the video when you're done. See if you got them. Then we're going to try to do a couple of analyses ourselves. Did you get them? All right, let's sketch a solution using this slope field. All right, and I want to see what happens when I go through 1, 1. And this is my differential equation. So all I've done is create a little chart. Now, I'm going to look at -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2. So all I'm going to do is look at different values of x and y across this range. Now here I want to look at, and this is just a sample, I can do anything I want. I just happen to be just kind of trading back and forth. So what is the slope at each of these points? Well, this is -2 times 2, so it's 2x minus 1, so this is -5. And this is -3, -3, -1, -1. Here we get a positive 1, 1, and then 3, 3, and then a positive 5. So we're seeing some symmetry here. Now, what I can do is come through at each one of these points, 1, 2, 3, 4. I mean, you can do this. -1, -2, 1, 2, 3, 4, -1, -2, -3, -4. And I could do these sketches. Now, I'm very interested in the solution that goes through 1, 1. All right, let's see if I can do this. At 1, 1, the slope is 3, so it's actually pretty steep. Let me just go on and do this. When x is 0, the slope is equal to y. All right? And when x is 0, okay, the slope equals y, so this becomes 1, 2, and you see this is going to quickly become very steep. Here it's -1, -2, we're done. When x is 1, then the slope is going to be 2 plus y. And we see this is going to be very steep as well. So this is just 2. This is 3. This is going to become very steep. And I don't want to do this a whole bunch. So when y is -1, this becomes 1. When y is -2, this is 0. And that's all I have time for here. Now I'm looking at this one right here, so I'm going to sketch this over. Now you can see as you continue doing this, these are going to, let's see, when y is 0, it's always 2x, so these are going to get really steep pretty fast. And you can see we've got these very steep answers, and even with your graphing things, it gets very, very challenging. Y prime, where is y prime 0? Well, it's when 2x equals minus y, or when y is -2x. Okay, so it's obviously 0 at 0, and it's also when y is 2x, so here is, you always want to sketch in the zeros if possible. Now, if you do this, and you keep doing this, you see this becomes more steep. I'm just going to kind of, all right, sketch through here. At this one, it's 0. All right, and then they start turning back down. What I asked for was, what does this solution look like through here? So it's going to wind up being something like this. And I shouldn't have crossed the line. Okay, you give this one a go and do and you want to go through 4, 0, 4. So give me a 3 by 3 grid around 0, 4. And when you're done, turn off the tape.